In this video, we're going to review some real quick integral concepts, and then we're going to begin talking about the Peel method. So this first question is from an old AP exam, and it says g of x is defined as what I would call area collector. It collects area from 0 to x of this function. What's g of 4? So if I plug 4 in, if it's really asking me for the area from 0 to 4 of f of x dx. Okay? So we basically just want to add up all the area. So here, of course, it's 2 by 1, so this is 2. Here we have a trapezoid. We've got a base of 1, a base of 2, so base 1 plus base 2 is 3, multiplied by 2 and divided by 2, this is 3. So we have total area of 5. So we just use our geometric shapes. Next, the average value of a function is approximately what? I just really wanted to remind you how to do average value again. Remember, this is the 1 over b minus a, so for us it'll be 1 over 8 minus 5. The integral from 5 to 8 of 2x over x squared minus 4. And this was on the no calculator section, and I think a lot of people look at this and they say, oh my gosh, we can factor that bottom and do partial fractions. You don't need to. U is x squared minus 4. Du is 2x. So dx. So this becomes 1 over 8 minus 5 times the integral of 1 over u du. And, we can change the bounds, if you remember how to do that. The old bound was 5. 5 squared minus 4 is 21, so that's the new lower bound. The old bound was 8. 8 squared minus 4 is 60, so that's the new bound. So the antiderivative, of course, of 1 over u is natural log, so we'd get the natural log of u evaluated at 60 and 21, and then at the very end we'll multiply that by 1/3. Okay, I'll leave that for you to type in. Certainly you could have gone back and plugged x's in and had x squared minus 4, and then you would have gone back to the original bounds in terms of x. But again, just a quick reminder of the area collector and the average value. The Peel method. I put up some basic things you know, or should know, from your pre-calculus course. Of course, this cosine squared plus sine squared is 1. We should absolutely know. Some angle identities, cosine squared. This comes from the cosine double angle identity. The cosine squared is equal to 1/2 of 1 plus cosine 2x. And sine squared is equal to 1/2 multiplied by 1 minus cosine 2x. Now, what the Peel method applies to is really just peeling off terms to get what we want for substitution to work. And we're looking to peel, at least at the beginning, odd functions of trig functions, or odd powers of trig functions. So sine cubed, I could rewrite as sine squared multiplied by sine dx. Okay, and this is the peel. I just peeled a sine off of sine cubed. Well, now I could rewrite sine squared. Okay, let me keep the color scheme going here. I'm going to rewrite sine squared as 1 minus cosine squared. And I still have that sine x dx left over at the end. But now, if I made u cosine, du would be negative sine. So I could make this negative, make that positive. So my integral becomes negative out front, 1 minus u squared du. Antiderivative is negative u plus 1/3 u cubed plus c. We now plug in what u was equal to, so it's negative cosine plus 1/3 cosine cubed plus a constant. And that's it. That's our peel method. So we're peeling off the odd power. We're peeling off one off the odd power to use some of the things we know to make some easier integrals. So let's try this one. Cosine cubed multiplied by sine squared. Again, we're looking to peel the one with the odd power, cosine cubed. So let me start with that. Let me rewrite this as cosine squared multiplied by cosine multiplied by sine squared. Okay. Now I want to get this down to have one. I don't want both cosine squared and sine squared. I'm going to replace that cosine squared with something it's equal to. So let me replace replace cosine squared with 1 minus sine squared. Okay, I'm just going to put a little underline. I replace that with this. Okay. I still have that cosine x. I still have a sine squared dx. But take a look at this. Let's make u equal to sine. So du is cosine x dx. So I'm going to be able to take out all of this with just a du. So my integral becomes 1 minus u squared multiplied by u squared du. Let me just point out where all this came from. Remember that u is equal to sine. 1 minus u squared, and then everything in blue here becomes du. Well, now I can multiply through, and I get u squared minus u to the 4th du. Antiderivative, of course, is 1/3 u cubed minus 1/5 u to the 5th plus a constant. Plug it back in, plug sine back in, so 1/3 sine cubed minus 1/5 sine to the 5th plus c. And there's our antiderivative.